Good morning. Welcome to Chapter 6, A History of Computers. For y'all who hate history, well, you probably won't like this chapter. Nah, it's fascinating how far computers have come and how we've tried to trace back the history of computers. So let's get. We trace back the idea of calculating devices back to the abacus over 3,000 years BC. So that makes it like 5,000 years ago. But we're more interested in computing technology in the modern age, and we tend to go back to the 16th, 17th centuries, and we're talking about people like Copernicus and Galileo, Newton, and what they were doing with the scientific advancement of that age, and looking at nature as a mechanical, understandable, repeatable device. And so we applied that to nature, and that meant our equipment and machines were built that way too. So starting in about 1642 is where we pick a date, and we'll see why that's important. But you can tell that we moved from mechanical devices to vacuum tubes to transistors. Yes, I can remember the little transistor radio that was about that big, could fit into the pocket of your shirt, and you could carry FM radio stations with you. Of course, nowadays we've gone beyond that, and we have not only the transistor, but we also have the integrated circuit. Uh, and now that same little radio, I have one that is not only AM, FM, but it's shortwave also. Just fascinating what we've done in just 50 years. So we start talking about the date 1642. And this is Pascal. Pascal was a mathematician. He developed a calculating machine for his father, who was a tax collector in France, I believe. And so he developed a machine for his father to quickly do the math on collecting taxes. Then we jump 150 years into the future to 1805, and we talk about Carthar's loom, and he developed a repeatable, programmable method for a loom that would read punch cards, and you could change the design of the tapestry that you was making by changing the punch cards. This is important because I remember doing work in Fortran on a mainframe computer, and we used punch cards for that, even in the late 70s at Auburn. So um, this was a giant step forward, helped to bring in the idea of math uh, production, which lowered the overall price of tapestries and rugs so that more and more people could afford to buy them. By the mid 1880s, you have a guy by the name of Babbage, and he designed his analytical engine, and this is extremely important. It's a major jump forward. His machine expanded upon the mechanical calculators. It even went so far as it could be a general purpose computer. It's a general layout of the modern computer. Um, you could even write programs for it, just like we do today. Unfortunately, nobody could build the machine. It was beyond the technology of the day to be built. And that's a real shame. Can you imagine in the 1850s if we'd have had computers where we'd be at today? It's also important, and we'll talk about it later on, but someone actually sat down and wrote code for Babbage's machine, and that person was Countess Lovelace, Ada Lovelace. Computer language Ada was named after her. So it's important that you remember the first programmer was a woman.
I'm not quite sure how to help you with that.
So that chimed in quite well, I thought. In the 1930s, we really began to make a giant jump with the idea of using electromagnetic relays, physical switches, which had to be open or closed, hint, ones and zeros. At the same time that U.S. was making these advances, England was making the advances, Nazi Germany was, again in Ohio State and in Bell Laboratories, you begin to see a giant jump. And using the Mark I computer, they followed the designs of Babbage and produced the Mark I computer. By the mid 40s, we're now looking at the vacuum tubes. Think of it as a light bulb that's in a partial vacuum. This speeds up the flow of electrons, and which makes everything a lot faster. Also in the 40s, you begin to have the hybrid computer showing up. They're using vacuum tubes and relays at the same time. Colossus in 1943 was used to decode the Nazi communications. This was based on a design by Alan Turing, a brilliant mathematician. He's the one that came up with the Turing equation to test artificial intelligence that is still being used today. You also had one called the ENIAC that came out in 46. Computers were used for also scheduling bombing runs over Nazi Germany because there could be up to 1,000 B-17, B-24s in these missions, and trying to get everybody over the target at the same time at different altitudes was a very, very complex problem. A little bit of history, the idea of the word computer comes about because people at one time who was doing the calculations by hand were called computers. And that was your job title, computer. And so you would do part of the calculations, and you think of a row of individuals, and let's say the row has 5 cells in a row. Those 5 would do their calculations and hand them over to the guy on the end, and then that column of 5 people, let's say, would pass it forward, adding up the rows. And so, hence, a spreadsheet out of real humans. This would all come about, and that's what's called computer and computing. So when the machine was able to do the job of those 25 people, well, think of those 25 people as being 125 people. It could do the job in minutes, possibly seconds, what those 125 people could do, and do it more accurately. Then that was your idea of the modern computer that we think of and what I'm using to do this video on. So anyway, no, these two were not general purpose computers. what I'm using today is be considered a general purpose computer, because not only can I do arts, I can do science on this machine. Think of it that way. And then I can be even more specified, and I can do business versus doing graphics design. Von Neumann is a very, very important name to remember. He's the one that came up with the idea of a storage program for a computer. He's the one that came up with the idea of using what we now know here, and with your CPU, your memory, your input output, and then add to that, we would add off of this a storage, permanent storage for memory. So this, a lot of times looking at this memory, we're thinking about only the memory that's active while the computer is on, which was still amazing for the time. And now we've gone to long-term storage, which would be your hard drives, your thumb drives. And of course, all hard drives are going to become thumb drives, if you haven't already read that in just modern life. The platter system of a hard drive is made up normally about 5 platters, and you write to side A and side B of both platters with actually read-write mechanisms moving on it. All that's going away to being thumb drives, and that's why laptops can become even thinner than they are as we move to that. Almost all modern computers follow the von Neumann architect, which is based on the design of Babbage from 1850. So it's amazing Babbage was so far ahead of his time. Programming was still difficult. Some of y'all would argue with me today and say it is still difficult. But back then, they programmed in ones and zeros. So a command, like when we moved to assembly language and used the command add, this is what it looked like originally, or what it is also still translated to inside the computer. When you hit run your program, those human commands that you've written are translated to those zeros and ones. And so you can see how complex setting switches were. It took 8 of them to get one word, like add. So you could have thousands and thousands of switches having to be turned to 0 or 1. In the 1950s, we saw the great advancement of transistors, which again sped everything up unbelievably and shrunk everything down again. So we're continuing to shrink the size of the computer, but increase the power of the computer. About every 18 months, we see a doubling of the ability of the computer to do things. Languages, as they begin to come out, these languages were more human-like. And Fortran, formula translation, is still used today for doing complex number crunching. It's just good, fast, and small. Like I said, I know a lot of physicists who still use this because of that. Lisp, you can still see Lisp in the artificial intelligence world, even though that is being replaced with other languages. BASIC has probably gone to the wayside. In most cases, you still see it sometimes. Beginning all-purpose symbolic instructional code came out of Dartmouth up in New Hampshire. Then COBOL is an interesting one. This is common business orientated language. It was developed by team. The Hopper is Grace Hopper, Admiral, United States Navy, female. Again, it's important. Females have been major contributors to the advancement of computer science. So also, as computers became more affordable, businesses were beginning to buy them, and you saw several companies come up and really get a hold of the market. IBM was one during the 60s. They kind of went away with the personal computer, but then they did all their stuff in the background, and now they are a major mover and shaker in the world of data science. So as you continue with the integrated circuit, then you move on to the microprocessor, which came out because of Intel in '71. This revolutionized the personal computer. And you can still see this family of chips has grown way beyond 40,000, 4,000, where in the 5, 6, 7, 8,000s are coming. Just amazing what has happened. At the same time, we saw the rise of an operating system. The original computers did not have an operating system. Well, with an operating system, you're able to manage your devices, that, and also what's happening with time sharing inside the computer and swapping jobs in and out. This allowed the computer to do multiple things at the same time. Just fascinating. This chart is really out of date now. I won't lie to you. You need to look at what has happened since 2009. You can just do a Google on the future of computers. Read about things like quantum computers. Yes, this is based on quantum mechanics. We're also looking at stuff of using light to store data, which means the computer would truly be moving at light speed. And so a lot is about to come over the horizon, and it will quickly come down to the laptops and all when that happens. In 5 years from now, we won't recognize computers probably like we do now, small, much, much faster. At the same time, this is going to revolutionize artificial intelligence even more so, which will revolutionize the idea of robotics. They're looking, some futurists say that by the year 2029, I believe it is, we will have a computer that is as smart as a human. Now, I know the joke. The joke is, well, that's not much, but you know what I mean. Having the capability of the human brain to be able to process as fast as the human brain does, and to storage data as great as the human brain, which basically your computer will have, think of it, of having the internet inside the computer. It would constantly be updating and learning. And because as our knowledge in the world is doubling, used to, you could say every 1,000 years, every 500 years, every 100 years, every 50 years. Back in the late 80s, when I was teaching an intro to computer course, we did it in calculating every 7 years. We showed the doubling of human knowledge. We're now down to every 13 months. We're doubling what human knowledge is. Just incredible what's happening out there. So anyway, we continue, and we see that, 75, founding of Microsoft. 77, you see the founding of Apple. In 1980, the PC, which is the big thing that revolutionized everything. 84, Apple came out with the Macintosh. Then in 85, Windows came out. Microsoft came out with Windows, which just was a game changer. Up until 85, we was doing a lot of things in DOS, and even through the 87 time frame, I was still teaching DOS courses with my wife, and we were having a blast teaching DOS. And it's amazing as doing system admin work like I do, we have gone back to using DOS a lot to do system admin, because with Windows you may have to click 10 times to get somewhere to do the work, and with DOS I just implement a command and it's done what I need it to do. You also saw in 85 development of C++. Java came along in 95, not JavaScript, just Java is talking about here. Smalltalk is another one of those very interesting programming languages. C++ and C are workhorses that you see a lot of times, or you don't see, because they're behind the scenes doing the heavy lifting. A lot of times we see an overlay program to make it easier to interact with what's going on in the background. You're seeing a lot of stuff happen in parallel. Course that came about, and that's a wonderful thing. That's really is helping. That's why you could have multiple programs running on the same time in your computer. Used to, you had one program running. You close that program and open up another program. With the operating system, you could copy stuff into memory, then close the program, open the new program, and then paste that, Control V, just like it is now, Control V into that new program. But I mean, that was a multi-minute process, whereas now I have two screens in front of me. I have the programs, one open in one screen, one other one in another screen. I just copy and paste, done. So you're seeing a lot of the networking on the internet. Of course, in this course, a lot of the stuff you do, you're accessing the images that are up on the internet and sending me the programs. Sorry, that's my Alexa talking to me, or my computer talking to me about messages coming in. So anyway, we will see more and more of everything being networked all the time. And some futurists talk about how humans could also be networked all the time. And of course, we say, well, I have my cell phone. That does that. I'm talking about devices implanted in us to help with memory, to help with the amassed amount of data that's out there, augmenting our human brain. A lot of strange stuff happening out there. Yes, the idea of a cyborg. This is again out of date. It's listing rich people like I don't care. But it is interesting. Most of them made their money through technology, and that's the way things will continue. Anyway, we are done with this chapter 6. Like I said, go and do some Googling. Future of computer, future of artificial intelligence, futures of cyborg, future of robotics. Just look, you'll learn a lot more. And the reason why it's important that you know that is that you are the ones in the undergrad school that are moving toward those jobs and are wanting to get a hold of those jobs that will be available and valuable to you in the future. I would always suggest computer security also as being one of those to look into because of all the stuff and how artificial intelligence will help with security, I believe. So anyway, have a great day, y'all. Bye now.